Welcome back to the second part of the tutorial. In this part of this full stack tutorial using AWS Amplify Gen 2, we'll learn how to create functions, first using Typescript and then using Python, and how to deploy them within the system created by Amplify as well as separately as a Lambda. So let's get started.
So for part 2 of this demo or tutorial, we're going to add these two buttons here. And then this one, when we click this button, it's going to go all the way to the back end, and it's going to call a Lambda function that is created using TypeScript in the Amplify Gen 2 system. So this one, it's actually going to call some Python function. In the Amplify Gen 2 as of October 2024, there is no provision directly for a Python function, but we will use another system called the CDK to create a Python function there, and then call that function from within the backend of this application. So the front end will call the backend, which is in the TypeScript, and then that will call the Python function. So over here, the code for this is in two places. So it's in the RenAI Helena Frontend Playground, and it's in the Helena Python CDK Playground. So, and then for both of these, there are tags. It's called v0.1 demo because we're going to continue to add to this. So if you get this one, then you'll have the exact code for this. And let's see over here for the backend in Python, it also has the version 0.1 demo. So I'm roughly following some of the documentation here, but it's not exactly the same. Okay, so for example, over here it says to create a handler in the Amplify function say hello / handler. And let's see over here, if I go to the front end. So the front end has, even though it says the front end, it has a little bit of the back end also. That's why it's called full stack. And it's in this develop branch currently. That's where the demo for this is. And then if I look at Amplify, I don't have the functions folder as this one asks you to create. So apparently we can do this without the functions folder, because if I did this exactly like it said over here, it was a little bit confusing for me when I added this. So I think I mixed and matched various documentation here and got this to work. So let's see over here, instead of doing this, where is this then? Where is this define function located? So let's see over here if I can search and define function. So actually this define function does not exist, and it's able to do this even without the define function by having it, I believe, in the data layer. And if I look at the data resources file over here, there's this thing called echo response. In this example, it has a thing called say hello, and it just says hello. But over here, what I wanted to create was whatever you tell it, it kind of echoes back with adding something to it. And then we already have this to-do thing going on from the template. So we want the to-do thing to work also. So let's see if I say, let's add a Python Lambda and that to-do part is also working, but so I don't want to remove it. So what you do is, this is a little bit confusing on how to do it, but in the Gen 2 way of writing this, what you create another return type, and then this return type, for example, the to-do only has content. You could add other things to it. This one, the echo response, has content and execution duration, and then it says a thing called query. Now this thing can have multiple things, like it can either have a query or I think, I forget exactly what it's called. It's a transformation or mutation, I think. Yeah, mutation. But this is a query where you just exit something and it returns back. It's not changing the data. And then you provide arguments, which has content here, and then it returns an echo response, and the authorization is allow public key, which is similar to this. So this is not too safe or secure. We'll talk about adding security in another video, but over here they have some other authorization type with the IAM, which is a little bit more difficult to set up in this example here. So, and then it says there's a handler, and it's coming from the echo handler. So this echo handler is being kind of defined functioned over here. So because it's been defined functioned over here, I didn't have to create another place where I did the define function, because it's already kind of done over here. And then I don't exactly know what happens if you omit the name. I think this name is used in the AWS console Lambda name. So if you don't provide a name, it might create some random name that's difficult to kind of search for. So it's probably better to create a name, provide a name here. But over here, we say that the handler is, I don't know why the define function didn't show up. Maybe when I searched for it, maybe it was typo. But let's see, over here, it's inside the folder echo handler and handler.ts. So now let's look at the example handler. The example handler just returns hello world. But in this one, what I've done is I've taken the input, which comes within the event thing, and then within the event you have to use the specific way within the Amplify systems. So it's not like exactly the same for any Lambda, but within the Amplify system, and depending on how you call the Lambda, you might have to do the arguments or not. But for this one, it comes within the arguments, and then the content is here. So it's not clear from here that you have to provide like arguments.content, or whether it'll just come in the content, but you do have to provide that. You can sometimes debug it. The way that I figured out what I need to put here is sometimes by just printing out the whole event and then figuring out how the event is passed. But over here, I just add a string called echoing content, and then I put it back into the return content, and I calculate the execution duration. I know I took it from some other part of a tutorial, so I didn't like invent this, but it's not like I mixed and matched different tutorials for this one. So I have it in the resources within the data folder. So the data folder has a resource.ts, and within that resource.ts I had to add a define function, and then I had to add this part within the schema, and then I had to create a handler, and that's, I think, about it. Let's see, in the back end, I didn't have to change anything over here because it's all within the data. There's some examples that I did that also worked where I needed to like add to this backend, but I found this one cleaner where I use the data layer. I think later, if I use GraphQL more heavily, the approach I describe here will be better. So besides that, there's nothing else. And now if I deploy this, to deploy it, and then you need to find your AWS app link. Once you find this link, and then over here, I'll create the access keys. I won't show it right now. And then once I put that access key, I can just deploy. Either I can deploy the main version, or actually this is set up so that if I commit to the GitHub repository, it'll automatically deploy. But if I want to just do a sandbox, then I can use the access keys here. So I'm in the right branch, in the right folder, and let me try the sandbox deploy. So it's npx ampx sandbox and the name of the profile. So if I deploy it in the sandbox, then I can run it locally. And we need to wait for the sandbox to be set up. So while this is happening, let me look at the Lambda functions over here. I'll use the administrator access to get in and view the Lambda functions here. And there was a Lambda function deployed, and you can see that this one is a table manager. That's probably not it. There's an echo Python function. That's also not it. So let me see if I search for echo. There's only an echo Python function. So because I did not name that function, it's now more difficult for me to kind of find the exact function. I know that it's a Node.js function, and I did this about a week ago. So this is probably the one. Let me see. And it comes up with this long convoluted thing that you can't really edit. You could, in principle, copy it to another place, reformat it, and make sure that that's the one that you should be looking at. But we could try over here to test it. And let's see, I think I might have a saved one. Let me make sure that this has the echo. Yeah, echoing Python content. So this is actually not the right one. This is the one that calls the Python function. And let's see this one. Custom S3, branch linker, bucket deployment. It might have been deployed a while ago, and because I didn't change it, it might have stayed the same. So I would imagine that there's one that got created in a sandbox. Let me see what happened to my sandbox here. So yeah, when you see this amplify outputs.json, that means that the sandbox got created. And so I should have a Lambda function that got deployed here. And in fact, there's like two Lambda functions. One is using, and then let me sort by last modified. So there's one that's here. That got changed about 3 minutes ago. So it's actually hard to figure out, when I change it, what part of the code changed over here in the AWS console, in the Lambda, because they're all named kind of cryptically, especially if you create a sandbox. And it's hard to figure out, whether something's in a sandbox. Let me see. If I try sandbox, then sometimes it shows up. But if I sort by last change, you can see that some of this I'm able to see, but it's still a little bit hard to figure this out. So let me see if I change the name here. If you remember, we had a thing here where we define function and you could put in a name, and we'll call it echo handler and name echo Python handler. Okay, so it just auto suggested a name here from the GitHub Copilot. And then actually I also want to change a little bit of this, what the handler does, and I'll just add a date here. Echoing content changed 2024 November 03, so that this will also change. And then the Python handler, I'll change that one also. Changed 2024 November 03. So save that. As soon as you save, you see that it'll try to update some of this. And let's see if the name is actually reflected over here. 12 seconds ago, echo handler, there's a name here that showed up a little bit. So I think these are the two that actually changed. So let's say the echo handler, if I want to test this from here, then I can test it using this. And I will, so you need to have this exactly in a particular format. If I test it just like that, then you'll see that it'll get an error, say undefined content. So you need to put this event JSON using arguments, and let's say content value 1, and put a comma. Let me say format JSON, and then let's see if I'll actually save this and say argument with content so that I can use it again and again. So I'm not actually sure that's saved. Hopefully that's saved. And then let's see, maybe there was a template already there for a function call with argument, but for now I'll just use that and see if so it's not allowing me to test here. I'll save it. There's an error in your JSON. Oh, that's why. So I think the error is I didn't have a quote here. And format JSON, and then save it, and then if I test it, now it's successful, and the output is echoing content changed to this value 1. The execution duration is this many, I believe that is seconds, so about 37 milliseconds. So you can see how this one's working from here. Now if I go here, it'll still it won't say it's still only saying hello world. It's not saying the content changed because I haven't actually deployed it to this particular URL. Because I did it in a sandbox, to run the code in the sandbox, what I need to do is I need to start the front end. So the front end is, I think, npm run start. I might need to do npm install if I'm running it for the first time. But if I start it, there's some problem here. So trying to build your app before starting the production server. Okay. Next, starting could not find production in .next directory. So I think what I have to do is npm run dev. Actually, in the last episode, I found that if you do the npm run build and npm run start, it will not update automatically if I change the front end. But if I do npm run dev, then looks like that's ready. And if I run it in the local host, if I say that, it would call that new Lambda function. So it's echoing content changed 2024 November 3 hello world, and that is because I sent hello world over here. Let me change that. That front end code is in the app directory, so that's the backend code. This app directory is front end code. Over here, instead of sending the content hello world, notice that to connect to the backend, what you do is you do something called the generate client, and then it will generate the client from AWS Amplify data. So that's the some library, and then when you do the generate client, you can use, if we look at the Amplify data over here, resource.python, we created something called echo response, and echo is the query and the return type is echo response, and that query takes an argument called content. So now if I go back here, what I do is client.queries.echo, because this name echo is coming from over here because we named it echo. If we named it something else, we'd have to call it with something else. And also the argument, we named it content, so that's why we have to say content. And let's change that a little bit. Hello from the front end, and then await just means that we don't want to do anything until all the data from this query has come back, and then we can create an alert message. Later in other episodes, we'll try to do streaming, where if we only get partial data, then we still update the user interface. But for now, we'll do this one. Let's see. Now I haven't saved it, so it'll still say hello world, and you see there's a little bit of a delay there, or I think it's not a delay, it's just it didn't click properly, but it's only maybe 40 milliseconds, so it's not perceivable to us. And then over here now, if I save this, because I did the npm run dev, it will kind of compile automatically. And then now if I hit this button, it'll say hello from the front end, and this part has been added by the back end, and this part is just the echoing thing from the front end. So now we know that it's going all the way to the back end and coming back over here. Now let's look at the code that does this in Python instead of TypeScript. So what I mean by that is this handler is actually just doing it in TypeScript right here, whatever it needs to do. But sometimes there are a lot of machine learning algorithms that are developed in Python, and we don't want to recode it in Node or TypeScript. So what we want to do is we want to do it in Python. There are multiple ways to do it, where we create a function directly in Python and then figure out how to call it. So that I found to be a little bit more complicated than the way I'm doing it here. So the way I'm doing it here is I'm replicating what I did here, where I created another query and I called it echo Python, and I created another return type called echo Python response. Because the return type is actually almost the same, I believe I could have used just the same return type, but I created two so that in case I want to change it later, then I can more easily change one and keep the functionality of this one intact. Everything else is the same, and there's a handler, echo Python handler. Now you'd think that you could write this directly in Python, but currently in the Amplify Gen 2, you can only write this handler in TypeScript. But that's perfectly fine for us actually, because this one is full stack, almost like a mono repo, where the backend and front end are in the same repository. But usually what we want is to have it in two different repositories. We want the front end in one repository and back end in another, so that we can change them independently. So let's see this one. So over here, what this one does is it uses a node package called got to call a URL. So this URL is now a Lambda function URL. By the way, we'll talk about Lambda functions if you already don't know about it, then in another episode on what it is, just from a theoretical point of view, or more a discussion point of view, applied theory point of view, if you will. But over here it just means that if you call this URL, or if you type in this URL, then it will call a function that is running somewhere in the cloud. And actually the way that lambdas work briefly is that if that computer in which that code runs is not on, it will actually create a computing resource to just run this function. And if there is a lot of load, then it may create multiple of those computers. If there are thousands or millions of front ends calling this, or other systems calling this system, then it will automatically spawn those computing resources. One of the beauties of the working in the cloud with Lambda functions. So this one, you can see message expected value line 1. So we didn't message this correctly, because this URL is actually expecting a post, and that's the way I configured it. So we have to create a post, and we're using this package called got. So got, let's say node.js. So if I look at got, so for this got to run, you actually have to install it first. So you have to do, let me put new node, npm install got. You have to do this. I already did that, so I won't do it again. So once you do that, what will happen is it'll put it somewhere in the package.json. I think it put it in the front end this time, though I think it's also used for the back end. So over here, you'll see somewhere that the got installed over here, and a particular version of got installed. And I found that I was trying to use AWS's API to do calls, but I found the got to be a little bit easier to use. And there's also another one called request. But with the request, it was difficult to, it was a little bit more complicated to handle the await. So what the await does is it makes sure that all the data from this call has come back before it does something else. So over here we post and create a JSON message where we put in the content to post to it, and again we put it in event arguments content, and we'll see in the Python code how we like kind of parsed it out, because we sent it, we could have sent it in any way over here because we are not following any Amplify conventions or anything like that, but I decided to follow a very similar convention so that the code looks similar. And then one of the complicated parts here is to figure out whether you have to send a string or a JSON. But basically it took me a little bit to figure that out properly. So you need to create a JSON from the content inside the event here, and then post it to this URL. If it's a get, then you can do a get, but I configured it to be a post, and I'll show you how just in a bit. And then the result, you have to change it into string, parse it, and put it back into a JSON, and then send it back. So it's a little bit of back and forth. And this message thing, so this message thing comes from how the Lambda returns HTTP calls. Okay, so now let's look at the Lambda itself. So this one I put in the Python CDK. Let's see, let's see if this is the one that I was working with. Let me actually open one where let me say open recent, and actually open folder, and I'll open the CDK playground. And over here I think I took it from another tutorial, and again I had to make a bunch of modifications from the tutorial. Basically what you need to do to run this, if you wanted to run it kind of locally, is to do the virtual environment. You need to do the virtual environment anyway because it has this CDK thing, and to run the CDK you have to put in the virtual environment. But you could potentially run the code locally to test locally also. I won't cover that here. We'll run it directly on the cloud. And let's see over here, go back to the README, and then we have to activate the virtual environment, and then we have to install the requirements, and then we have to do the CDK synth to synthesize the thing, and then when it's time to deploy we have to do the CDK deploy. So I won't go through the whole thing because I already did that, but let me show you some of the parts where to show you how it works. And because this environment is not correct, I think that's why this is showing with a yellow squiggly line there. Let me see if I can force it to connect to that VENV. Let's see over here if I can find the right virtual environment. So the I haven't created the virtual environment in this one yet. So let me create the virtual environment. Terminal, new terminal, and I will say Python -m venv.venv. Created. Do you want to select it for workspace folder? Yes. And then I need to do source vnd activate, working on a Mac, and then I'm inside that virtual environment. I need to install the requirements. Pip install. I'll also upgrade it because it keeps giving me warning that you need to upgrade the pip. So pip install requirements, and it's installing a bunch of these CDK requirements. I don't think I used anything else. So while that's installing, let me show you the code. So it's creating a app from using the cdk.app, and then there's a thing called Python CDK stack, and that's actually a package inside of this. It's not from the CDK. The CDK is just here. We just named it Python CDK because I think I was following a tutorial and that named it Python CDK. I probably would have named it slightly differently if I had done it myself from scratch. It's still installing, so some of the squiggly lines are still there. But over here, this construct and things like that, looks like it installed. So this went away. Stack, Lambda. So you extend the stack, and you can name it anything you want, and you have a constructor here. And within the constructor, we are creating a Lambda function called hello handler, and over there we're also making sure that we print out the URL of the handler. So, and this URL should match, if I go here, the URL I use here. So I would probably put this in an environment variable within the Amplify system so that I don't have to like hard code this URL. But for now, for this tutorial, I'll leave it there hard coded. And then I can choose the runtime. I have some name, and then the handler is hello.handler, which comes from inside this folder called Lambda, and that Lambda looks like I don't really need to import it. I just create a folder called Lambda, and then there's a package, or in Python the name of the file is the name of the package. In some cases, the module is the name of the folder, I believe. And then inside of this package there is a function called handler, and this is what handles the input to this. And you see that it has event and context, just like in the TypeScript case, but this one is designed to handle post messages. So you have to give it post messages in a certain way, even though here it says get. This is just Python notation. And again, going back and forth between string and JSON was the most complicated part of this. And the way that I figured it out is to print this out in a debug message, what the event contains, and then trying out various combinations of this. Because sometimes it looks like a JSON, but the whole thing is inside of a string. So you have to get the string, convert it into a JSON, and then get parts of it inside of so you could also do a string search, but we're going to use the JSON parser here. And then for the return, you see over here, if you don't have this try and exception, then you get a very cryptic error message, which just says error 503 or 500, and then it's very difficult to debug. But if you put this as an exception here, then the error message, because you sent it as the error message, you can decide to do over here, if you got a message that starts with error, then you can add some code here to kind of do things based on the error. You don't necessarily have to show the user the error message exactly as it is, but you could handle the error more intelligently. And also it's good for debugging, because you still get something back. And then you construct a response. where you need to put it in the body because it's a HTTP request, and then you send the response, but the response itself has a message here. So that's why over here we had to read the message over here. So we could have called it something else, and then we could change it to this. And then over here, so let me change this a little bit so that when I deploy it, it deploys again. Let me change this to this date, echo from Python Lambda 2024 November 03, and then I'll save this. So now the way that I could have set up the GitHub thing so that when I push to GitHub, then it deploys through the CDK to AWS, or some other kind of CI/CD. But for now, what I'll do is I'll use the CDK deploy method. So the way to do that is CDK deploy, and then I have to put the profile that gives me the permissions to deploy it. And I found that I need to add some Lambda deploy and execute permissions. So also over here, somewhere here in the CDK stack, I have given it permissions. So I added the function URL so that it can be called using an URL. And I think I added permissions somewhere here. Let me see if I can find where I added the permissions. Not here, not here. .py cdk.json. I think this is an auto-generated file, the JSON one. So I don't exactly see the place where I'm adding the permissions for this to be run, but I think the way that the permissions are handled in this case particularly, that I'm just creating a URL, public URL, and as soon as I create that public URL over here, there are no like a permission structure here. When I go to the episode where I add more security to this, then I'll go through how to do the permissions more properly. But over here currently, I think as soon as I create this URL with the auth type of none, yeah, that is the permission here. Because I have an auth type of none, I can call this from anywhere. So this is a public URL. So the only security is security by obscurity, which is where the name of the URL is a little bit complicated, and it's hidden in the back end, so it's not directly accessible from the front end, and that's one of the reasons I put this in the back end. So the front end only calls this, and then the back end then actually calls the actual URL. So this kind of unique signature here is again a little bit hidden from the user if there's a prying user. And then let's see if I do that, if it works and whether it updates this function itself, where I change it to 2024 November 3, and update in progress, and it updated the hello handler. So I was worried that it would change the function URL every time, but what I actually found is that for the most part it keeps this one constant. So if I change this part, I don't really need to go change this because it keeps it as it is. So over here, I forget whether I wrote this one first or this one. but I might have written this one first and left that empty, or left it to be some random thing. But then to test it, I first finished this and got this actual URL, and then pasted it into this function over here in the other part of the backend that calls from the Typescript to the Python. And then that actually works. So let's see if it's working now. If I go here, the front end is still running. And if I go here, this particular backend is also still running. So it should just work. So let me close that one. Let me close that one also. And this is running in the local host. So if I now call this one, it should say echo from Python Lambda 2024 November 3, and it's calling the new Python Lambda. And if I go back here in the console, if I look at the functions, and if I clear this out and say last modified, for some reason, maybe because it's not refreshed, 2 minutes ago. So this one's, because it's in Python, I think Lambdas, they were originally done with Python, it's easier to actually see what's going on over here. And we'll cover more about adding layers and so on in a different part of the tutorial. So in summary, to call a Python function that runs in the cloud from this Next.js front end, what I did is I created this Python function in a CDK using the AWS CDK, which is not Amplify. So AWS CDK is the Cloud Development Kit, and there's a bunch of CDK tutorials. And then on the Amplify side, what I did is, because I was using Gen 2, I used the Gen 2 notation to create a, in the schema, I added to the schema a query and a return type, and a handler in TypeScript. That actually calls the Lambda that's written in Python using the URL that comes from the deployment of the Python function. And then I made sure that the JSON and strings were parsed correctly. And voila, everything works. So let me know if there's part of this tutorial that you don't understand well and you want me to elaborate. So thank you.